Hello, this is Mrs. Myers. We're going to do 11.5 volume of pyramids and cones today. Um, you've done some volume before. We are just going to apply a new formula to the pyramids and cones, which come to a point at the top and have a polygon as the base if it's a pyramid and a circle as the base if it's a cone. This says to look for the patterns, but in the interest of time, I'm going to go straight to the formula. It turns out that the volume of anything that comes to a point, like a pyramid or a cone, is just like the volume formula we learned, BH, capital B, capital H, area of the base times the height, except this time it's divided by 3, or you can think of it as 1/3. So 1/3 the amount of cubic units can fit in a pyramid than could fit in a rectangular prism of the same height. Okay, so the trick here is to remember that what we talked about with pyramids before is that inside every pyramid and cone is this hidden right triangle with the slant height as the hypotenuse, the apothem as the base here, and the height, capital H, height of the whole prism, as the height of this triangle as well. So often we're going to need to use Pythagorean theorem to solve for one of the missing pieces of that triangle to be able to find the actual volume. So let's do a couple of examples. The entrance to the Louvre Museum in Paris is a square pyramid with a height of 21.64. So that means inside here, all the way down to the base, right, is going to be 21.64. So to do the volume, we need BH over 3. So we need to make our list, and our list is just going to include B and H. If we were asked to find the surface area and the volume, we would just make one big list, and it would have B, H, slant height, and perimeter would be on here also if we were finding surface area. But we're just doing volume, so we need the area of the base and we need the height for volume. Well, they just give us the height. So how are we going to get the area of this base? We know that it's a square pyramid, and they show us here that the length of the side is 35.4. Well, if it's a square and the length of the side is 35.4, then from the middle of the base to the edge, this apothem here, would be half of that. So the apothem would be half of 35.4, which would be 17.7. So to get the, actually we didn't need that. Sorry, back up. I was thinking we were finding surface area, in which case we would have needed that to find the slant height. Sorry, back up. We don't really need that because all we need is area of the base. And if we know that one side of the square is 35.4, then to find the area of the square, we just need to do 35.4 squared, or times itself, and get 1,253.16. So area of the base is 1,253.16. Height is 21.64. Volume is just going to be area of the base times the height divided by 3. So when we do this, we multiply these two together first, then push equals, get that total first, which is 27,118.38. Then divide by 3, and you get 9,039.46. And so the volume is measured in cubic meters. And that would be our answer there. If we look at another few problems here, number 2 says a sports arena shaped like a pyramid has a base area of 300,000 I think there's an extra 0 on there. Just cross that out. 300,000 feet and a height of 321. Nothing tricky here. We're just going to multiply those together and divide by 3. Here, the volume, number 3, the volume of the pyramid, they're going to make us work to find the height here. Okay, so they tell us the slant height is 25. They tell us that it's a pyramid with a side of 40. So the apothem here would be half of that, which is 20. Remember, it's half of it only when it's a rectangle or a square base. If it's a hexagon or whatever, we have to find the apothem in a more complicated way. But we're going to use Pythagorean theorem here. We've got h, 20, and 25. So we're going to do 20 squared plus h squared equals 25 squared. So when we do this, 20 squared is 400. 25 squared is 625. So h squared is 225. And the square root of that is just 15. So I should be using capital H here. They used lowercase, but let's use capital H here. Capital H height of the pyramid is 15. So the height of the pyramid is 15, and I'm assuming this is a square pyramid because they didn't tell us that it wasn't. So we'll say that the area of the base is 40 by 40, or 1600. So the volume is just going to be 1600 times 15, and then divided by 3. Which is 8,000. My calculator just died. 1600. Yes, 8,000. Then it's cubic feet. Okay, so I think you get the idea there. Let's move on to cones. Oops. So down here, it turns out the volume of a cone is exactly the same thing. 1/3 the volume of a cylinder that would be the same height. Because it just comes to a point, so it's going to be less volume. Oops. So area of the base times the height, again, divided by 3. Remember that area of the base, it's a circle, so it's pi r squared. So if you ever, this should be a capital H, so if you ever need to find radius or whatever, you can use that other formula. Okay, so let's just do one. Let's skip down to this oblique one. What's the volume of the oblique cone in terms of pi? If it's oblique, which means it's kind of tilted over to the side, or whether it's standing straight up, the formula is going to be the same. So we need our list. We know our height is 25. Area of the base is pi r squared, which is pi times, looks like radius is 15, which is 225 pi. So volume is going to be 225 pi times 25. Do that first and then divide it by 3. Don't forget. 225 times 25 is 5625 pi over 3. So we're going to divide by 3, and we get 1875 pi cubic feet. This would be the exact answer. And if you wanted the approximate as a decimal, you would just multiply 1875 by pi and get 5890.49 cubic feet. Okay, occasionally, oh boy,